Welcome all, and this is the fourth lecture on thermodynamics questions. I'll try my level best to include very good questions. So in this we have I'm doing some questions on thermodynamic relations, then properties of pure substances and unsteady state flow. Okay, chalo, let's take the first question. Dear students, consider a rigidly perfectly insulated, let me take perfectly insulated, this is perfectly insulated container partitioned into two unequal parts. These are unequal parts. Actually, this is the container. One second, please. Yeah, this is the container and this is insulated and it is divided into two parts. Unequal, he said. Okay, let this volume be V1 and let this volume be V2, and you know that volume is an extensive property, so therefore the total volume is V1 plus V2, no problem at all. Now unequal parts by a thin membrane as shown in the figure. One part contains 1 mole of an ideal gas. Let us assume that the left part, let's take this portion, okay, let it contain 1 mole of ideal gas, left portion, maybe right also, don't worry. Ideal gas at a pressure Pi, temperature Ta. The pressure is Pi, temperature is Ta. While the other part is perfectly evacuated. There is nothing here. There is no material medium on the right side. The partition, this partition or the membrane ruptures and the gas fills the entire volume and the equilibrium pressure is Pf, and that is equal to Pi by 4. The equilibrium pressure Pf is given as Pi by 4. Here it is given. It is Pi by 4. So what is happening? Now this partition is ruptured, or now finally the entire gas is occupying this volume. So can I say the final volume is equal to V1 plus V2? Exactly. So the final pressure is given by Pi by 4. Initial pressure is Pi. Initially, the gas was occupying only this volume. Now this partition is ruptured. Now the gas is expanding completely. So it is occupying the entire volume of the container. No problem. Now, and final pressure is Pi by 4. If Cp is the molar specific heat at constant pressure and Cv is specific heat at constant volume, R is universal gas constant, then have the same units as that of that, then the entropy change is okay. Dear students, he has not said about the entropy change. Is he asking for the gas or is he asking for universe? It's not given clearly. But in this problem, there is no need. Look at, it is already insulated. Whenever the system is insulated, there is no heat, there is no transfer of energy to the surroundings in the form of heat transfer. So in an adiabatic system, the surrounding entropy change is 0. All these I had explained in my earlier classes, because as there is no heat transfer to surroundings, there is no change of entropy for surroundings. So whatever the entropy change is occurring for system, it is same as that of the universe, because universe entropy changes system plus surroundings. As it is adiabatic, there is no change of entropy for surroundings. So thereby, whatever the system entropy is changing, that is also equal to the universe entropy change, because surrounding entropy is 0. I repeat, entropy change of universe is equal to entropy change of system plus entropy change of surroundings. Here, as it is adiabatic, there is no entropy change of surroundings. So whatever the system entropy is changing, it is same as universe. But here the system is ideal gas. But now we should identify the process. Whenever you are trying to do questions, you should identify the process. And you know, it is an example of free expansion. The gas is expanding against nothing. It is unrestricted. There is no restriction for the gas to expand. It is expanding freely. And moreover, he gave it as an ideal gas. Moreover, he gave the system as an ideal gas. So I taught in my classes earlier, in my regular courses, whenever an ideal gas is undergoing free expansion, initial internal energy is equal to final internal energy. Initial enthalpy is equal to final enthalpy. Initial temperature is equal to final temperature. All these I had explained in my earlier classes. So here Ti is equal to Tf. Now, you know, my dear students, we know temperature relationship. We know pressure relationship. The initial pressure is Pi and the final pressure is Pf. So just find out the entropy change of gas, that will also be equal to the entropy change of universe also. So it doesn't matter whether it is universe or system. In this problem there is no difference because the surrounding entropy change is 0. Now I have given in my regular classes the entropy change for ideal gas. I gave you in 3 forms. One is temperature volume, the second is temperature pressure, third is pressure volume. So here temperature pressures are known to me. Initial final temperature relationship, initial final pressure relationship is known. So let me write in that form. Cp ln T final by T initial minus R ln P final by P initial. All these I had given. How do we derive this? TdS is equal to dH minus VdP. And for ideal gas, PV is RT if you take per 1 kg. So if you want entropy change, it will be dH by T, you divide with T, minus V by T into dP. So therefore, what is V by T from this? V by T is R by P. So this V by T can be written as R by P, and dH can be written as for ideal gas Cp dt by T. This is T. And ds is this. Now integrate this equation. So if I integrate, integral ds is s2 minus s1, Cp is constant, dt by T is log T, log Tf minus log Ti, so it will be log A by B. And similarly R, dP by P is log Pf minus Pi, so it is log Pf by Pi. No problem at all. This we know clearly. So whenever you have doubt, you should be in a position to derive equations. Therefore, blindly don't remember equations. You should know how equations are coming. Then only you will be solving questions easily. Now dekho, S2 minus S1 is equal to Cp ln. The final temperature is also equal to the initial temperature when an ideal gas undergoes free expansion. So therefore, the final temperature can be written as initial temperature Ti minus R ln. The final pressure is given. Okay, let me write Pf by Pi. Don't worry. So what is Ti by Ti? It is 1. Log 1 is 0. Ti by Ti is 1. Log 1 is 0. So S2 minus S1 is equal to minus R ln Pf by Pi. So therefore, if you take minus inside, it will be R ln Pi by Pf. So therefore, this can be written as R ln initial pressure, and the final pressure is Pi by 4. So this 4 will go to the top. Therefore, R ln 4, Pi is gone. So the answer is R ln 4. Let me check whether that option is there or not. Yes, it is there. R ln 4, R ln 4. This is an expected question, though it is easy. Now let's go to the next question. Now read this question. For a single component system, the saturated vapor is represented by G and the saturated liquid is represented by F, and they exist in equilibrium. Okay. Now, he said for example, there is a liquid vapor mixture. The saturated vapor we are designating with G and the saturated liquid we are designating with F. Now he is asking, what is this? Is Ug is equal to F? Absolutely no. If you see the diagram, this is F and this is G. Definitely the saturated vapor values are greater than the saturated liquid values. So I know very well Ug is greater than Uf. Yes, so this is wrong. It cannot be equal. And you also know that enthalpy of vapor is greater than enthalpy of liquid because there is a latent heat hidden in it. So this is also wrong. And entropy of gases is more than the entropy of liquid. So this liquid has less entropy compared to the vapor which is in gaseous state. So Sg is E greater than Sf. So this is also wrong. Now he says Gibbs free energy, and please see, let us check whether it is correct or not. Let me check, sirs. A second. 3 options are wrong, but 4th option is right. But why? Because one of the options should be correct. It's not MSQ. So therefore, at least one option is correct. So therefore, when 4 are wrong, obviously the 4th one, when 3 are wrong, 4th one should be right. But if it is right, why? Let us see. Dekho ek baar. Let us take TS diagram. Now, this is the saturation temperature. This is the saturation temperature. And this is our SF. And this is our SG. This is our SG. Okay. Now, You know, phase change, whenever the phase change is occurring, my liquid and vapor, they are at the same temperature, thermal equilibrium. My liquid and vapor, they are at the same pressure, they are in mechanical equilibrium. And there is no change in composition if it is water, liquid H2O and vapor H2O. So there is no change in chemical composition. So therefore, now all are in equilibrium. So therefore, phase change is an internally reversible process, because whenever you are heating, every time internally the liquid and vapor temperature and liquid and vapor pressure is absolutely same. They are in equilibrium every time during the phase change. So if it is reversible, internally reversible, then I can write ds is equal to d dash q by t. And you know, phase change is occurring at a constant pressure. For constant pressure, what is the heat transfer? Change in enthalpy. So therefore, change in entropy is equal to, for phase change, it is latent heat by temperature, which is saturation. Look at sirs. Now, entropy change is equal to, what is latent heat? Latent heat is during phase change, the constant pressure heat transfer. Constant pressure heat transfer is what? Phase change is occurring at constant pressure. Constant pressure heat transfer is change in enthalpy. So therefore, I write it as dH. I write it as dH by T. So therefore, dH is equal to TdS. No problem at all. देखो एक बार, dH, it is Hg minus Hf, phase change. Hg, this is Hg, this is Hf. Hg minus Hf is equal to T into entropy changes Sg minus Sf. अब देखना, तो Hg minus Hf, here I write, no problem at all. 1 second please. Eraser, okay. Now, let me check this. So you know this equation. So during phase change, don't worry sirs, don't worry, absolutely fine. No problem at all. Now, you have seen that dH is equal to TdS. So therefore, dH is, the phase change is occurring. So during phase change, the enthalpy change is this, and temperature is constant, Sg minus Sf. Let me repeat. So it is from F to G. So enthalpy change is Hg minus Hf, Hg minus Hf. So this can be written as Hg minus Hf is equal to Tsg minus Tsf. So you bring this to this side, Hg minus Tsg, you bring it to this side and you throw this to this side. So minus will become plus. So Hf minus Tsf. So what is this? H minus Ts, it is Gibbs free energy. So Gg is equal to H minus Ts is Gibbs energy. So that is, it is saturated liquid and it is saturated vapor. So Gg is equal to Gf, and this is correct. This is the right option, my dear students. Is it okay? Chalo. Let's proceed and move to the next question. Let's move to the next question. ये वाला ले लेंगे. हाँ जी. This is a good question. Consider a vessel of steam at 180 degrees. The initial steam quality is 0.5 and the initial volume is 1 meter cube. 1 second. 1 second please. The initial volume is 1 meter cube and the initial dryness fraction is given as 0.5. Any other data given? Any other data given? The dryness fraction is 0.5 and the volume. The vessel loses heat at a constant rate under isobaric conditions. Means at a constant pressure it is losing it, so that the quality of the steam reduces to 0.1 in 10 hours. Matlab, the dryness fraction, final dryness fraction is 0.1 and it is occurring in 10 hours. It is occurring in 10 hours. Okay, 1 second please. No problem. 1 second please. Yeah. Now, what is the data given in 10 hours? The thermodynamic properties are given here. They are given Vg, Vf, Ug, Uf, Hg, Hf. The rate of heat loss in units check karna, kilojoule per hour, and it is a fill in the blank question. Okay. Now, dekho. Look at carefully. If I plot the diagram on Ts, observe clearly, it is a constant pressure process. The initial dryness fraction is 0.5 and the final dryness fraction is 0.2 because he said it is isobaric. Yes, this is isobaric, this is isobaric, this is isobaric. And you know, in a constant pressure process, heat transfer is equal to change in enthalpy. In a constant volume process, heat transfer is change in internal energy. In a constant pressure process, change in heat transfer is equal to change in enthalpy. He is asking heat transfer. So heat transfer in 1 to 2, that is a constant pressure process, is equal to change in enthalpy. And the enthalpy is changing from 1 to 2, therefore it is H2 minus H1. But please note down that both these states are under wet region. They are in wet region. So H2 can be written as, look at carefully, H2 can be written as HF plus X2 into Hg minus Hf because it is in the wet region. Similarly, H1, this one is also in the wet region. So it will be Hf plus X1 into Hg minus Hf. This is also in wet region. Both are in wet region. So I am using this equation. So heat transfer is equal to H2 minus H1. What is H2? Hf plus X2 into Hg minus Hf. Okay, no problem at all. Right. Now, this is H2 minus H1. What is H1? Hf plus X1 into Hg minus Hf. See, please look at carefully. As 1 and 2 are at the same pressure, for 1, this is F. For 1, this is G. Similarly, for 2, this is F. For 2, it is G. So for 1 and 2, my F and G, that is saturated liquid and saturated vapor, are same. Therefore, I am not writing HF2, Hg2. Because for 1, it is F. For 2, it is F. For 1, it is G. For 2, it is G. So now, if you want the heat transfer, and you know this Hf minus Hf gets cancelled, so Hg minus Hf is common. So you are left with X2 minus X1. So I will take X2 minus X1 into Hg minus Hf. This is the heat transfer. But please note down, the enthalpy is given in kilojoule per kg. The answer will be in kilojoule per kg. But he is asking in kilojoule per hour. Observe carefully. So let us try to find out the heat transfer. What is X2? It is 0.1. And what is X1? 0.5 into Hg minus Hf. Let's check, sirs. What is Hg minus Hf? Hg is 2778.2, 2778.2, and Hf is given 763.21. 763.21, and these enthalpies are given in kilojoule per kg. Let me calculate. Says 2778.2 minus 763.21. You should also calculate into 0.4. Correct. And we are getting this as minus 5.9. So I'll take it as 806 kilo. What does negative sign show? It is losing heat. So therefore, this is one. But this is not the correct answer. Let's check. We need this is the heat transfer for 1 kg. But I want the total heat transfer. देखो एक बार. तो कैसे करेंगे सर? Very simple, my dear students. Very simple. So how do? I need somehow I have to calculate the mass. देखो यहाँ पे volume, initial volume is given. So initial volume is given as 1 meter cube. Somehow if you can calculate initial specific volume, mass is anyway constant. It is losing heat under constant pressure conditions. So specific volume is volume by mass. If you calculate mass, mass will be volume by specific volume. So volume is already given. Somehow if you can calculate specific volume, the problem is solved. And initially it is in wet region. So therefore the initial specific volume is given by, as it is in wet region, so I write this equation. Therefore V1 is equal to Vf. What is Vf, sirs? 0.001127 plus X1. What is the initial dryness fraction? It is 0.5, and Vg is 0.19405 minus Vf is 0.00127. So let me check 0.00127, 0.19405. Let me calculate this value. So 0.19405 minus 0.00127 into 0.5, okay, plus 0.001127. So I will get the specific volume as 0.0975. This is the specific volume. Let me check once. 0.19405 minus 0.00127 into 0.5 plus 0.001127. So this is 0.09. Okay, so let's calculate mass. So volume is 1, and the specific volume is 0.0975, and you will get the mass 0.0975. Let me check. And you are getting the mass as 10.25 exactly. So the mass is 10.25. So I got the mass. Dekho. So what is the heat transfer? It is 806 kilojoule per kg. We got the heat transfer as 806 kilojoule per kg. Forget about the sign, because he is asking what is the heat loss bola. Already he used the word loss. So whenever he uses the word loss, already negative sign is loss. Don't put negative. So therefore, the total heat transfer will be equal to 806 into, this is for 1 kg, and we got mass as 10.25. So if you check the unit, this is kilojoule per kg and this is kg. So therefore, the answer will be in kilojoule, but he is asking per hour. All this is taking place in 10 hours. So if you want in 1 hour, so therefore, he gave the complete process is occurring in 10 hours. So therefore, if you want per hour, this is so many kilojoule, you want per hour. So the process is occurring for 10 hours. So therefore, now you will get this into 806, okay, divided by 10. So the answer is 826.5 kilojoule per hour. This is the right answer. Please check calculations. I am not sure. So because you please check calculations and check whether it is correct or not. So the answer is 826 point something. Okay, right. Now we'll go to the next question. Dekho, this is also good question. Water is heated at atmospheric pressure from 40 degrees to 80 degrees in two different processes. In process 1, the heating is done by a source at 80 degrees. In process 2, the first water is first heated from 40 to 60, and by second source 60 to 80. Okay, okay, no problem. So he is actually, let me explain what the question is. Dekho, water is heated from 40 degrees centigrade to 80 degrees centigrade. This is process 1. In second case, it is heated from, ek baar dekhna, 40 to 60. In one case, it is heated from in process 1, it is heated by a source at 80 degree, and in the second, it is heated from 40 to 60. Acha. In two stages, it is heated. So here it is heated from 40 to 60, and again from 60 to 80. Matlab, in first case, it is heated. Let me read the question carefully. In process 1, where is that? In process 1, heating is done by source at 80. So you are heating from 40 to 80 in a single stage in process 1. In process 2, the water is first heated from 40 to 60, then again from 60 to 80, again from 60 to 80 by another source at 80. Identify the correct statements. Please, ek baar check kar lena. In one case, directly it is heated from 40 to 80. So what is the temperature difference here? It is 40 degrees. And in this case, it is also heated from 40 to 80. But the difference initially is 20 and the second is again 20. What does it mean? It means, my dear students, understand carefully, and H is equal to U plus PV. For liquids, you know, liquids occupy less volume compared to vapor. So for liquids, the volume is insignificant compared to this. So therefore, your PV is very small. So H is almost equal to U for liquids. H is almost equal to U for liquids. But U can be written as CT. So as the temperature is same, dekho, as the initial temperature and final temperature, as the initial temperature, final temperature is same, in both the cases, enthalpies will be same, because enthalpy is, specific heat is assumed to be constant, and temperature in both the cases, initially it is 40, finally it is 80 in case 1. Initially it is 40 and finally it is 80. Forget about intermediate stage, final ki baat kar rahe hum. We are talking about final. So as temperatures are same, enthalpies will be same. But see the quality. Here the difference is very large. And you know, if you want a process to be reversible, REV, if you want the process to be reversible, what should be the gradient or the difference? It should be very small. So here the difference is 40, very large. Here the difference is less. So therefore, this is tending towards reversible. So compared to this, here irreversibilities will be less. This is tending to reversible. I am not saying reversible. So if you bring this, I mean, from 40 to 80 in infinite number of stages, for example, 40 to 41, 41 to 42, so on and so forth up to dekho 79 to 80. So now if I bring in infinite stages, it will reach reversible. But it compared to this is reversible. The irreversibilities are less in second case. So this is tending towards reversible. I never said it is reversible. There is a difference between tending to and actual reversible. So as the difference is very small, it is tending to reversible. एक बार options देख लेंगे ना. Let's see options, dear students. देखो, enthalpy change of water in process 1 is greater than enthalpy change in 2. It is wrong because in both the cases it is 40 to 80, 40 to 80. So this is wrong. Enthalpy change in process 2 is greater than no. Process 1 is close to reversibility. Process 2, देखो which process is close to reversibility? जिसमें difference कम है. In second case the difference is very small. In process 1 the difference is very large, so it is not tending. So process 2 is closer to reversibility. This is also a good question, my dear students. Okay, chalo. Now let's not waste time. Fatafat we'll study so many questions and we'll try to do it. Okay, chalo. ये question है, देखो. Please look at 1.2 meter cube rigid vessel contains mass कितना दिया 8 kg of saturated liquid vapor mixture at a pressure of 150 kilopascal. The enthalpy of the mixture is it is a liquid vapor mixture, means it is in two-phase region. एक second रुको. Whenever it is in two-phase region, देखो एक बार, let me write it on TS diagram somewhere here. So if you want, it is in two-phase region. So if you want the enthalpy, it will be HF plus X into Hg minus HF. Already HF is given. So if you want enthalpy, it will be HF plus X into Hg minus HF. HF is 467.13 plus X into Hg minus HF. Hg is 2693.1 and HF is 467.13. Okay, no problem. So if you want to calculate enthalpy, I need the value of X. How do I calculate X? Very simple, sirs. Here mass is given, volume is given. Can I calculate specific volume? Yes. Specific volume is equal to volume by mass. Mixture specific volume. So यहाँ का specific volume. So volume is 1.2 and mass is 8. So you will get the specific volume. How much is this? So please take care of calculations because I have not calculated these values. Please, it's a request. Take care of calculation. I may be wrong also. So this is 0.15. So you know, whenever it is in wet region, the specific volume of the mixture is given by X plus VF plus X into Vg minus Vf. So already the specific volume is calculated by us. It is 0.15. And Vf, what is Vf? Here it is given. This is Vf, 0.001053 plus X into Vg. What is Vg? 1.1594 minus Vf. Vf is 0.001053. So therefore, let me calculate एक बार calculate करेंगे सर. 0.15 minus 0.001053 divided by 1.1594 minus 0.001053. So we are calculating the dryness fraction. I got the value as 0.1286. So please check these values. I am not sure. Please एक बार आप values check करना. Just put the value of X here. How much is X? X is यहाँ पे put करना. X is 0.1286. Put here 0.1286 into 2693.1 minus 467.13. Please check these values एक बार. Plus 467.13. And I am getting the value as enthalpy of the mixture as 753.35. 753.35. 753. So I got the value as 753.35 kilojoule per kg. Please, it's a request to all of you, check calculation part. Okay, this is the question. Next. This is a good question. एक बार पढ़ो एक बार. This is a very good question. This is from unsteady state. An insulated rigid tank of volume 10 meter cube. Okay, let me draw that. There is an insulated rigid container. Note down, it is a insulated rigid container. So I write here rigid. And what is the volume given, dear students? Volume is 10 meter cube and the pressure is 1 megapascal, 600 Kelvin. Volume is 10 meter cube and the pressure is 10 megapascal and the temperature is also given. Let me check. 1 megapascal and 600 Kelvin. It is 600 Kelvin. It's not 10 megapascal, it is 1 megapascal. It is 1 megapascal. Let me erase this. Right, no issues. Chalo, let's proceed, my dear students. Now, what is he saying? It's a very good question, sirs. A valve connected to the tank is opened and it is air. Please note down, it is air. It is air. It is allowed to escape until the temperature inside the tank drops to 400. Okay. Okay, now actually there is a small valve here. There is a small valve here. Through this valve, air is allowed. These are all initial conditions. And volume, I am not writing V1, V2 because it is a rigid container. So as it is a rigid container, V1 is equal to V2 will be equal to V. Volume is not changing. So as it is escaping, let me show you the final condition, sirs. Let me show you the final condition. No problem at all. It's a rigid container. Okay. Now, the final temperature is given as 400 and we don't know what is the final pressure. Let me check. Dekho, the final temperature drops to 400. The final temperature drops to 400. 1 second, please. 1 second, please. Hello? Yes.